Hello and welcome to our FSAE Electric Powertrain Design presentation. This is the team by Tony Hamre, Mason Evans, myself, Greg Kirchmar, and Michael Giortino. You can see a bit of an overview of the car, but the individual sections of it we're going to go into with further detail later.
Pre-made Energis battery packs were sourced using Samsung 18650 batteries in a 10 parallel 72 series configuration resulting in 252 volts and 200 amps. The entire assembly is designed to be modular for easy assembly and maintenance. Selecting the correct high and low voltage connectors were crucial to ensure they were UL and IP rated to be reliable. This also guarantees that maintenance can be done safely.
Looking at the next phase of the accumulator, we can see the cooling method that we chose for the battery system. To make sure this thing is nice and simple and maintains the temperature we need, we decided to go with air cooling using a pair of 800 CFM fans, which operate the vehicle at about 31 degrees C. Behind the accumulator, we can see the main drive system, including the MREX 228 motor, the chain drive, and the required parts to make that all function. The mounts themselves were designed by Mason Evans. The safety shrouding you see on here, required by the FSA rules, was designed by me. Additionally, I added the chain tensioner at the bottom to make sure the chain stays on the sprockets.
Since the motor assembly physically spins around, a motor mount can only be fixed to the right side of the motor. Since all of the stresses are transferred to that side, the mounting frame was slightly overbuilt, having a safety factor of about 12.
An aluminum radiator with dyed water as the coolant, located at the right rear of the vehicle, will be fitted with AN fittings and rubber hoses to cool the motor and motor controller. This cooling system will dissipate about 9 kilowatts of heat from these components and help keep the car running optimally during all racing events. The Orion 2 battery management system and Reinhardt P100DX motor controller are located within the newly designed subframe. The BMS will monitor and ensure that the batteries are operating safely, and the motor controller will monitor and limit the performance of the motor. Using Optimum G lap simulation software and this vehicle's performance specs, this vehicle's performance on the 2019 FSAE Lincoln Endurance track was 111.2 second lap time average over 15 laps, which is very competitive to the 2019 endurance race results.